Hello, I'm Thaddeus, and in this video we'll talk about aging at a cellular level. I'm sure we all know how vastly different a young person looks from an elderly. Well, if you're not too sure about this photo, let's have a short lesson.
Lights, camera, action! In the movie Saving Private Ryan, we can easily spot the signs of Matt Damon growing older in a moment. His hair starts to visibly grey, wrinkles start forming all over his face and neck, and his skin starts to sag and become loose. And maybe even off camera, he'll start to feel back pain and trouble walking back home. From the moment we are born, everyone, regardless of the multitudes of differences between you and me, we all share this same phenomenon called aging. But what exactly is going on inside of us? Today, I'll share about inflammation in our bodies. We can identify inflammation from the progression of these 5 signs. Firstly, heat in the area, followed by redness and swelling. In the more severe stages, we feel pain and even loss of function, which means organs like our muscles or liver can't work properly. Inflammation isn't a bad thing. Normally, acute inflammation helps with fighting off infections and recovery of injured tissue. However, as we live on, things like excess or unhealthy food, toxic chemicals, medications, and bad lifestyle habits can throw the balance of hormones and molecules off in our bodies. That's when low-grade chronic inflammation comes in, resulting in pains and improper organ function. The above-mentioned activities are triggers of the NF-κB pathway, which is involved in switching on inflammation. First, pro-inflammatory molecules from outside the cell, like cytokines and PAMPs, bind to receptors such as the tumor necrosis factor receptor, toll-like receptor, and TB cell receptor. The signal then travels across the cell membrane, activates IKB kinase complex, IKK for short. The activated IKK complex then catalyzes phosphorylation and polyubiquination. Subsequent degradation by the 26S proteasome then releases NF-κB dimers. These dimers then translocate to the nucleus, binds to DNA, and activates the downstream gene transcription of many inflammatory proteins. Eventually, it could lead to metabolic diseases, problems with glycosylation, and potentially cancers too. Thank you for listening.